Good afternoon, class. It's Mr. Hale. Today we're going to be learning about thermal energy and heat. We've already started on that. We're going to go down to specifically how to deal with specific heat and calculating the specific heat. We've already talked about temperature and temperature scales, the Fahrenheit, Rankine, and Celsius. We talked about absolute zero, the coldest temperature you can possibly have, how heat transfers from hot to cold. Then we talked about the three types: conduction, convection, and radiation. Then we talked about what conductors and insulators are, but we really want to focus on this equation here, the specific heat. Okay, specific heat is the ability of a substance to absorb energy and not change temperature. We're going to give that the symbol C. If you look here in the equation, you're going to have this symbol C. It's a number that actually scientists have looked up for you. They've sat there at tables, they figured out how much heat it takes to heat, how much energy it takes to heat one substance up. So they'll sit there, they'll take a known amount of heat, put it under a frying pan, and see how much temperature that frying pan has gone up. Okay, we know that the frying pan heats up faster than, let's say, a piece of wood. So the frying pan has a higher specific heat, the ability to absorb energy without changing temperature, compared to the piece of wood. That will change temperature a lot harder. It's going to take a lot more energy to get that wood to change temperature. So we really want to focus on this equation. Q equals mc delta T. Remember, delta, that little triangle, is the Greek symbol delta, represents temp change. And so it's going to be C, the specific heat, a number you get from a table, times the mass of the object, because mass is important, times the change in temperature. That delta T represents the change in temperature. Now, I'm going to pull up a table and a little thing for us to work at. So we're here looking at this, and we want to be able to calculate the equation. So we're going to take the equation. Q equals M, capital C, delta T. If I give you a mass, let's say my mass is 40 grams, okay, and we're saying this is a mass of 40 grams of, let's say, platinum, okay, what is the specific heat for platinum? You look at the table, and the specific heat for platinum is 130. And let's say I want to change that temperature 10 degrees. What equation would I use? I'm going to use a top equation. I'm just going to take 40 times 130 times 10, and that's going to give me a number. Why don't you guys try to calculate that really quick, and then we'll give you that answer in about 10 seconds. If you need more time, make sure you stop, calculate it, and then restart it, and you're going to get 52,000. Since this is energy, this is going to be measured in joules. So you're going to get a measure of 52,000 joules of energy if we do this right. Notice, when we do these, the numbers are going to get really big. When we're dealing with energy like this, we're going to get really big. Now, we're going to erase that and get to a new problem. I'm going to leave the equation there. You can always rewind if you guys are getting if you need more time. Now, let's start. Let's say I want to change, 80 grams, so a mass of 80 grams of concrete, 30 degrees. So I know my change in temperature is 30, my mass is 80. Now, I need to know the specific heat. I need to know this number. So I need to go C. Since I'm dealing with concrete, I find concrete in the table. I'm going to do it a C of 850. Okay, take some time and calculate that answer for me. Okay, if you need time, stop your thing while you're still calculating, but your answer is going to be 2,040,000 joules of energy. That is going to be your number. Let's erase this one more time. We're going to start with one more problem. Now, let's say I want to take 245 grams or kilograms of silver, and I want to change that 85 degrees. So I want to take 245 kilograms of silver, and I want to change that 85 degrees. Why don't you guys try to calculate that? All right, 240 kilograms of silver. I want to change that 85 degrees. Try to do that calculation, and then we'll give you the answer. Okay, if you need more time, make sure you stop. Let's go do the answer. A mass of 245. A specific heat of silver, got to find silver in the table, is 230. And a change in temperature I gave you of 85. All we got to do is multiply the three numbers together. You're going to get 4, 7, 8, 9, 7, 5, 0. So you're going to get 4,789,750 joules of energy. Well, I hope that was helpful to you guys. I hope you guys learned a little bit about what's going on. So let me go back to our system. And just remember, Q equals MC delta T. That is on your equation sheet, and we'll work with that a little bit more. This is Mr. Hale, KD2 LPM for K2 GSG.